My name is Mario, and I'm going to talk about ECMAScript 6 and from an text perspective. So first we're going to learn what ECMAScript really is, what we can use it for, and why it has security relevance. Thank you very much. Is the sound okay? Almost okay? All right. So, as mentioned, my name is Mario. I lead a company in Berlin who's focusing on penetration tests. I'm also a researcher and postdoctorate at the Ruhr University in Bochum. I wrote some books, wrote some papers, and lead some projects, so you can have a look at these. And if you want to ask me questions after the talk, you can just follow me on Twitter or just send me an email. What we're going to talk about today is ECMAScript 6. And just about 3 days before this talk, when I just finished the slides, the consortium that is specifying this new language, which we're going to learn about today, just randomly decided to say, let's not call it ECMAScript 6 anymore, let's call it ECMAScript 2015. So, all right, that's interesting. So essentially I would have to change all my slides, but I thought to go with the head to the wall and not do this at all. So I'm still calling it ECMAScript 6, but technically it's called ECMAScript 2015. Maybe this year, let's see how they're going to call it next year, so let's wait for that. What we're going to talk about today in this presentation is, first of all, learn a little bit about the history of JavaScript. What is JavaScript? Why do we have it? Where is it coming from? Who invented it? Who kind of extended it with features? And where is it going to be going? And we're going to go into detail about, of course, ECMAScript 6, the new hot version of JavaScript that is right now being specified and already during the process of specification being implemented in various browsers. So we see ECMAScript 6 support in Firefox, we see ECMAScript 6 support in Chrome, and we already see ECMAScript 6 support in the new versions of IE that you can have a look at in the tech preview versions. The people behind ECMAScript 6 are already working on ECMAScript 7, so it's kind of a floating process, like a flowing process, and it's never going to end. It's kind of a little bit like with HTML, where they decided to make it like a living standard. So they also kind of go the way with ECMAScript 6 and kind of continuously add extensions, new features, and new ways of executing code, which is quite nice. What we're also going to learn about, of course, today is the security impact thereof, because it's a security conference, right? So we want to know what kind of features in ECMAScript 6 are there that help us as penetration testers, or that kind of shoot us in the foot as developers, because we don't expect that they can actually execute code in situations where we deem to be safe. We're going to have a look at a bunch of example vulnerabilities. We see a lot of code examples, so it's going to be a rather technical talk. And we're going to learn about practical exploitation, about vulnerabilities that could not be exploited with ECMAScript 5, but can indeed be exploited with ECMAScript 6. And at the end of this presentation, we're going to have a small conclusion, and we're going to have a look at the spyglass and see what the future is going to bring for us. What we're going to not talk about today is, or what we're not going to kind of achieve today in terms of goal of this presentation, is completeness. So we cannot cover all the new features of ECMAScript 6 because there's just too many of them. Also, there's a bunch of features that are just plain boring and we don't want to talk about them, and I don't think that they have any security relevance, so we can ignore them. We're also not going to see any explosions, so there's not going to be any mega bugs at the end of the presentation that are like affecting everything, but we're rather going to have an overview about little things and the details and the subtle things in this new edition of features for this language, and see what they kind of give us. What we're further not going to do is have any real deep dives, as in let's have a look at one feature very specifically and go to the core of this and have, for example, like a browser source code audit, because this is also not one of the goals of the presentation. I'm rather attempting to give you an overview of what is there, how you can use it, and hopefully these features are actually going to be implemented the way we're going to present them today, or those features are going to be remaining the way they are already implemented as they are today. Oops. So when Googling and searching about the history of JavaScript, I found this one sentence and it kind of stuck out. And it says, Netscape, the inventors of JavaScript, also wanted a lightweight interpreted language that would complement Java by appealing to non-professional programmers like Microsoft's Visual Basic. Does anyone note the snarkiness in there? I did, and I found it quite awesome and laughed. So JavaScript is technically not a real language for real programmers, so if you do write JavaScript, no, you're not a real programmer. Of course, that's not true. JavaScript has quite some moved history. So it started all in 1994, when the language called Mocha, or LiveScript, was released, and it was first implemented in Netscape 2.0 Beta 1. Soon afterwards, it was renamed to JavaScript with Netscape 2.0 Beta 3. And even in that year, in 1994, people started to implement server-side JavaScript. So when people come to you these days, say like, hey, we're using server-side JavaScript and it's hot and it's awesome, you can tell them, well, people did that in 1994, so where is the hotness? In 1996, Oracle applied for the trademark JavaScript. I don't really know why, because they kind of saw, hey, that's an awesome term, let's apply for a trademark. And JavaScript, aka JScript, which is fairly different from actual JavaScript, first time appears in Internet Explorer 3.0. So in Internet Explorer 2.0, there was no real scripting, they just introduced it in the third version of this amazing browser. And IIS, Internet Information Services, Microsoft Server, also starts supporting JavaScript on the server. So again, let's talk about hotness of JavaScript with the server. In 1997, the very first edition of ECMAScript, so namely ECMA 262-1, was published. And now you might ask yourself, what is ECMA? And we're going to cover that in a minute. Microsoft decided to rename JavaScript, or their implementation, from JavaScript to JScript because they realized that their thing is kind of a bit different from actual JavaScript. And the big problems that the developers of this language were facing in 1997 was actually to fix Y2K bugs, specifically in the date methods, so the methods of the date object. In the year Y2K, so in the year 2000, ECMAScript 262 minus or dash 3 was published. So there was kind of a little bit of a movement on the specifier side. And JavaScript as such reached the version number 1.5. And you might already be wondering, so some people say ECMAScript 262-3-1, JScript, JavaScript, version numbering. How is this homogeneous? How is this kind of unified? Guess what? It's not, because everybody put their own label on it. And in the same year, the trademark JavaScript was actually granted to Oracle. So now Oracle owns the term JavaScript. I'm not sure if that's a good thing. In 2005, the Mozilla people decided to release an incredible beast to JavaScript, to the JavaScript world, because they published the first working version of E4X, which is ECMAScript for XML. If you've ever looked at these things, you would be very surprised what you can be doing inside JavaScript with raw XML structures. This feature was so grotesque that it led to so many possible attacks, like inclusion attacks, cross-site scripting attacks, and so on, that they decided after some time to remove it again. So it's like, yeah, that was kind of a mistake, we shouldn't have done that. In the same year, ECMAScript 262-4 should have been released, but wasn't, because they decided, no, actually it's not ready yet, let's wait a little bit. However, they decided to release JavaScript 1.6. And ultimately, in the year 2009, ECMAScript 262-5, so what we know today as ES5, or ECMAScript 5 was released, and then quickly followed by ECMAScript 5.1 in 2011. And in the very same year, also Node.js was being published. So it's about almost, yeah, let me not kind of estimate this, almost 15 years after they first ran JavaScript on the server. There's an amazing table on Wikipedia that is showing the version madness and kind of illustrating who decided to call which version of JavaScript / ECMAScript / whatever script how, and kind of implies how much chaos in there. So a lot of specifiers, a lot of cooks, a lot of people kind of stirring the pot, and no one really know what to do and how to call it, and it was like never in any way unified. So this kind of chaos is always good for a bunch of vulnerabilities and always good for a bunch of crazy features. Talking about crazy features. Back then, we had JavaScript from the Netscape side, and we had JScript from the Microsoft side. And JavaScript and JScript are fundamentally different. So in JScript, so Internet Explorer's interpretation of what scripting should be like in the browser, you could, for example, take an arbitrary object and just simply execute it as a function. You're like, what? Yes, you could do that. So you would take the location object and you would just execute it as a function. If you, for example, execute location and pass a string, then the browser would load this location. This is not working in any other browser, only IE. Because the standard way would be to say like, okay, we can assign something to location, but we cannot execute it. It gets worse, because Microsoft's Internet Explorer not only supported JScript or JavaScript, but they also decided to support Visual Basic Script, and they still do today. It's kind of a little bit hidden as a feature, but you can still run Visual Basic Script in IE 11, and you will probably be able to do so in IE 12 with some tricks. And you can see that they have completely different formats. So here, for example, we have the native date literal, and the native date literal starts with a hash. That is the only way of executing any form of code that's starting with a hash. Well, not the only one, because there was more possibilities, and there will be more possibilities because they're currently specifying something that is immutable objects that also would start with a hash. We saw a lot of extensions to JavaScript because JavaScript itself wasn't fairly powerful, so developers and especially browser vendors decided to want more and implement things on their own. In IE, we saw the ActiveX object, which was the most horrible idea that they ever had, and the Mozilla people thought that the idea was so horrible that they tried to imitate it and created the Gecko ActiveX object that luckily never took off. In Gecko, so in Firefox-based browsers, we also had a feature that was called sharp variables, which was able to kind of give us the feature of circular references, another format that was natively starting with a hash, which was quite nice because you could do things like eval location hash, and location hash always starts with a hash, and you didn't have to worry about, for example, trimming off the hash and making sure that the code is valid because location hash itself was already containing valid code. Then we had the possibility to execute weird code by using E4X, as already mentioned. So you can see here we have the possibility to just execute an alert and then have HTML or XML-ish characters in there, and that would still work. We had the possibility to, for example, use legacy setters that used a completely proprietary syntax and weren't supposed in any browser but Firefox. We could just say a setter equals alert and then say a equals 1, and then we would alert 1. No parentheses at all. We also had the possibility, for example, to use E4X setters, which was again a different format for setters, and we could say function : and then have an array accessor and then directly append the term setter equals eval and then just say x equals alert 1, which is completely impossible and syntax that is not specified anywhere. Or, and that was like from my perspective, like the most exciting version, we could say x equals and then use like a keyword string saying @mozilla.org/js/function and then execute x : have an array index to alert and then execute the whole function because it would give us the alert function from the window object. Luckily, this is not working anymore, so these kind of extensions have all been disabled after some time when people realized, so that's not a good idea. Another horrible feature that they implemented and supported for a long time in Firefox, and I think they stopped supporting this in Firefox 16, was Java in JavaScript. So inside your browser with JavaScript, you could run Java code. It was called Live Connect. The documentation on that is very scarce. You will find few pages on the MDN, the Mozilla Developer Network, but you find a bunch of pages on the Oracle documentations on Java itself because it's kind of coming from the Java core and was more or less pushed into the browser, and then at some point they decided that this is like a huge security risk and they should kind of remove it again. So you would be able to execute packages, .netscape, .javascript, .jsobject, .getWindow, then pass in a reference, could be anything, and just simply execute alert. Needless to say that you could execute more than just the alert, but that is not the scope of this talk. There's interesting parser peculiarities that we see, for example, in Internet Explorer. So Internet Explorer has weird behavior when talking about JavaScript inside HTML, because of course you can run JavaScript anywhere. And running JavaScript inside HTML brings more complications. So this snippet here would be executing in Internet Explorer, and it would be executing the code alert1. And if you have a look at this piece of code, you would say like, this should never execute alert1 because we have an opening script tag here, we have a declaration of a variable here, then we're starting something in a string, then we're ending this with a comment, then we're closing the script element, and then we have something standing right in the page, printable in the document, then we have another comment here, then we're closing the script element. But still, based on some parser weirdnesses, this would ignore this part, completely strip off this part, and then execute alert1 because it would be thinking still to be in the script tag. So you can kind of see there was weird things that were implemented, and luckily most of them got removed. But those weird things gave us, as penetration testers and attackers, the possibility to sometimes execute code in situations where we would think it's not possible. And those zones where we can inject into and think we can execute code, but then again we cannot, I would like to call dead zones or useless injections. Luckily, all those weird features are meanwhile flagged as weird, and the MDN, so the Mozilla Developer Network, makes very, very, very clear that you should not use them at all. So I do not know how many warnings you can put in a page, but you can see you have this frame here, you have like the pink tone, you have this warning here, and yet another warning here, and saying like, don't use sharp variables ever because it's a bad thing and it's non-standard. Thanks for that. So one of our questions might be, how do weird features or syntax extensions to a standard, to an existing standard, impact the attack surface? Well, like I said, sometimes in an injection scenario you have a dead zone. You inject into something, you can get your content in, you can get your codes in, but you cannot execute them. So there is a vulnerability, but it seems to be unexploitable, and that is of course frustrating, because you would like to execute something, but you cannot, because the language as such forbids it. But if there are syntax extensions, then it might be possible to actually still execute this thing, because you would be abusing those syntax extensions, read something that is off standard, realize that something works that shouldn't work, and then get your code to work, at least in one specific or two specific browsers. One example would be the hash character that I showed earlier with the date object in VBS, or the sharp variables in Firefox. If you have an injection that is involving something containing a hash, in JavaScript you cannot do anything because it's not valid. It will always give you a syntax error. However, if you have a peculiar feature in one specific browser, then you might be able to do so and turn it around and actually execute something. And my point is here that I believe that even allowing one single character or adding one single character to the engine to be supported and execute code might have an amazing impact, because it might help you to turn injections into something that works for you versus injections that are going into dead zones and don't do anything at all. And like I said, when you have the situation that you inject into a website or application or a Chrome application or whatever, and you realize that you can put code in, but you cannot execute it, that is extremely frustrating. One example would be that you have the possibility to influence the parameters of a function. It would be looking like this. The function is being declared, you have the first parameter, you have the second parameter, that would be your injection, and maybe a third parameter, and then stuff is being done and you cannot influence it. And you would be injecting here and you would be realizing, I'm in the code, I can influence the code, but I cannot execute anything. Maybe if the business logic is allowing me, but not by nature, not by default. So this is frustrating. Or another situation would be if you, for example, influence the label of a literal. So we have an assignment here var a equals, then you have the part that you can influence in your injection, and then you have the value of the object. But again, this is frustrating because you can do stuff, but you cannot execute code just so, but you really want to. And the good thing is that with what we're going to see soon, with ECMAScript 6, you can indeed do so. So the focus of this talk is to find ways of executing code that formally did not work. So ways of making your injection work if it formally didn't. Before we do so, we have to talk about something a bit more boring and see how the standardization process works in ECMAScript 6. And who loves standardization, right? It's such an amazing, wild thing. Standardization, yay. So let's see who actually sits behind JavaScript and standardizes it. Because apparently there's vendors, there's developers, there is other institutions, there's Oracle, and there's ECMA. You might be wondering, what is this ECMA thing? Like, how do they own the rights to standardize JavaScript, and why? And how did this all happen? Well, ECMA International, the European Computer Manufacturers Association, was founded in 1961, and they standardize a lot of things. They, for example, standardize CD-ROMs, or the CD-ROM Yellowbook format, or the C# language specification, or the universal 3D file format, whatever this is. They also standardize OpenOffice XML. They standardize the HVD, the holographic versatile disk. Not sure if anyone has ever seen one of these. They also standardize the OpenXML paper specification. They standardize ECMAScript, and they even standardize JSON. And ECMAScript, aka JavaScript, is just one of many, many standards that they're working on, and it's known as ECMA 262. So whenever you read this number, you know, that's actually JavaScript. ECMAScript itself was developed by vendors and a bunch of people who were kind of pushing new features into the language, and was specified and standardized by the ECMA organization, and they called it ECMAScript. So technically, JavaScript, JScript, and ECMAScript are a bit the same, but then again, under the hood, they're not. And the work on specifying JavaScript, aka ECMA 262, was beginning in November 1996. So it's a pretty long time ago that they actually had to look at this and make sure that everybody uses it the same way, which no one ever did. So Microsoft decided to go with JScript, Netscape decided to go with JavaScript, ECMA decided to call it ECMAScript and have like a kind of standardization body, but no one really followed this thing just loosely, vaguely here and there, and there was always subtleties where they derived and deviated from the standard and gave us as penetration testers more possibilities to find bugs and execute code. The first edition of ECMAScript was specified in 1997, the second one in 1998, the third one in 1999, and so on and so on and so on, and now we're talking about ECMAScript 6, aka Harmony, which is being specified right now and hopefully done by the end of this year, and already being implemented in browsers. And as penetration testers, if there is like an entirely new language arriving in our browsers, this is an amazing thing, because we need to learn this language, we need to fully understand it and fully understand its capabilities to be able to exploit its shortcomings. So, ECMAScript 6. We're finally there. The new JavaScript, the new way, the language for the web. ECMAScript 6 is supposed to be an extremely powerful language, more powerful than JavaScript ever was. It was initially announced in the year 2008 by Brendan Eich, the inventor of JavaScript. And it was supposed to be the successor of ECMAScript 4, which was never released. ECMAScript 4 was kind of amazing because it brought us a lot of features. Should have gotten packages, should have gotten namespaces, early binding, static typing, classes, destructuring assignments, but they never made it. So it was always kind of close to be published, but they never published it. And eventually they decided, nah, let's not do it. Let's not go with ECMAScript 4. Let's just publish ECMAScript 5 and then later on ECMAScript 6. There's many places where you can get information about ECMAScript 6. One of this would, for example, be the ES Discussed mailing list. There's a lot of violence going on this mailing list, so if you're like faint-hearted, you might not want to go there because it's a bit tough. There is the ECMAScript wiki, which is a bit more moderate and nicer, so you can get like more distilled information there. And for example, from Mozilla, there is a page on the Mozilla wiki that is called ECMAScript 6 plans, where they kind of outline which features of ECMAScript they're going to support in the browser and which ones are already supported. So there's a lot of sugar for developers, but there's also a lot of sugar for attackers. Because those mentioned dead zones, those areas where we can inject into but not do anything, they are kind of vanishing, they are disappearing, and we now can indeed execute code in these areas, and in even more areas as well. If you want to have real practical information about ECMAScript 6, you should have a look at the ECMAScript 6 compatibility table that is being maintained by Yuri Zaitsev, aka Kangax. This is one of the most amazing documents on the topic because it shows you precisely which engine and which browser supports which feature and how the features develop, always with code examples. So there is no guessing work to be done. You just have a look at the code, you check if it works, you see precisely which browser supports what, and you have a full overview on every single relevant ECMAScript 6 feature on there. Amazing piece of work, and if you want to dive deep into this language, have a look at this table. Now, let's talk about security relevance. I already mentioned that we're not going to have a look at all ECMAScript 6 features because there's just too many of them. And as also mentioned, some of them are just plain boring. We don't want to learn about new functions that have been added to the math object and do some calculations because we really don't care. Well, at least I don't. Maybe you do. But the features we're going to have a look at are the features that have security relevance. So the features that might help us in penetration tests to get injections to work when they otherwise wouldn't. And this is the list. The almighty list of features that we're going to have a look at, which is arrow functions, which is generator functions, Unicode escapes, templating strings, which is absolutely amazing, symbols, which is one of the mystery features that no one really understands, but if you have a deep look into this, you're like, oh my god, not really. Symbols, that's what they do? Then we have modules, where you would think, okay, modules, what is this? Are they even part of the language? So, no one really knows, because sometimes they enter the spec, and then they leave the spec again, and then they come back, and like, what is this going to be? We're going to talk about reflection, so JavaScript finally gets a reflection API, and we're going to have a look at some mixed things that are not really categorizable and still be interesting. And as you can see here, our goal is to eliminate the dead zones, to find more areas for injections where we can execute code where we formerly couldn't. So, arrow functions are quite amazing. They also have a quite amazing name because they kind of nicknamed it with the fat arrow. And the reason for that is that they indeed use a fat arrow, so you have the equal sign and then the greater than, and this is basically the way to create functions now. So formerly in JavaScript, you would create a function by declaring it and saying function, space, then the function's name, or anonymous function, then parentheses, then curlies, and then the body of the function. This is all gone. This is all the old style. What we do today, what the cool kids do in terms of creating functions, is they use arrow functions. So they have the label a equals, then parentheses, then the fat arrow, and then the body of the function. So there is no curlies anymore, and there is not even the need for using parentheses. So we can see that we can save characters, and one of the motivations for creating fat arrows or arrow functions was to actually save characters and have a shorter notation to create functions. That this also means that you have the possibility to create a function that is not using any parentheses, and that many systems filter parentheses to avoid code execution. Well, this is a side effect. So what you can, for example, do is do something like this. You have the label A, you have the parameter A, then you have the fat arrow, and then you have this construct here, alert, backtick, 1, backtick. Now we think like, what is this? This cannot possibly execute any code. And it shouldn't, but it does. Why? We're going to see this later on. So Another interesting problem with arrow functions is the scoping. So in JavaScript, you often have to deal with the scope. Where are you executing? Are you executing on window, or are you executing in a different scope that is isolating you from window? Are you in strict mode, and you don't, for example, can use this as a reference to window? Or are you executing in non-strict mode? With arrow functions, this all changes. So if you, for example, run this piece of code in classic JavaScript, ECMAScript 5 and below, which would be like an anonymous self-executing function, and you would say return this, you would of course get window back, and that is expected. If you, for example, run your function in strict mode, it's like a protective measurement, for example, so you would define the mode to be run as the strict mode, and then you run the anonymous function, the anonymous self-executing function, and you would say return this, then this is undefined. This is extremely amazing for sandboxes, of course, because they can make sure that there is no possibilities to accidentally leak the window object. And the JavaScript sandbox wants to make absolutely sure that the window object is not being leaked, because by leaking the window object in the JavaScript sandbox, you bypass the sandbox and you can execute arbitrary code again. However, if you use an arrow function and say use strict, and then assign var dollar equals dollar fat arrow this, then you will get window again. You're like, okay, so in a regular function, this is resolving to undefined, but if you use an arrow function and it's resolving to window, that is weird, and this can be very, very useful, especially if you test the sandbox. And it's similarly, for example, if you do it like this, you have the label, you have a parameter, you have a literal here, and you specify inside this literal that you want to use the strict mode, which is also possible, so you can have modular strict mode declarations, and then return this, and you will still get window back. And there are still discussions about that, whether this is the good idea or whether this is a bad idea, so we do not really know yet how this is going to end up, but right now you will get window back, so technically if this is being executed in a sandbox, the sandbox is busted. Then there's another nice thing that is also useful to bust browser-based or JavaScript sandboxes, and that is generator functions. So developers always had the need to create functions that generate values. And that means, in a way, that you create a function that you can start, and it runs and runs and runs and runs, and then you stop it from the outside, so it stalls at that point, and then later on you go back into the function and kind of restart it, and it starts exactly where it stopped, which is extremely useful. So they call the generators. They already support generators, but not natively in JavaScript 1.7, and in JavaScript 1.8 a bit more, but now they have like a native new object for that. And a generator looks like this. You have the function declaration, and you have an asterisk, and then you have the name of the function, and then you do stuff, and you don't return, but you yield, so you yield values. So you can call the function by just executing it, but executing it doesn't do anything because it doesn't start the generating process. So you would then, after executing the function, call its next method, which is like a native method of this function, and then it actually starts working and doing stuff, and then you can yield things. So executing it, and then accessing next, and then accessing value, and then you get the values back that you're kind of generating here. So those things can run indefinitely and do stuff for you, and you can stop them, and you can restart them if you want to, and it's extremely amazing for example, single-page applications or everything in JavaScript that has to run for a certain while. Well, the interesting thing is here that you see we have a syntax extension. We don't say function space label parentheses curly anymore, but we say function asterisk space label parentheses curlies, which is kind of new. And what is also new is the fact that those functions do not use the function constructor as like their basic object, but they use the generator function constructor. So that is quite amazing. So if you ask for the constructor of this function, you will not get function back, or the function constructor, but an object that is called generator function. The function constructor in JavaScript is tricky because it accepts strings and it executes the strings as code. The generator function does as well. So if you have a generator, then you call generator's constructor, and you say generator constructor string alert 1, executing this and then executing next, then you have the alert. You might say like, okay, that is kind of boring. How is this useful? We're going to see this in a second. You can do other possible constructs here. You can, for example, say you define this function, and then you have the asterisk, and then the label, and then you have the yield, and then you have another asterisk to make sure that it's yielding properly, and then you give back the alert, and then you call the next, and then of course it would alert as well. But this is maybe interesting if you, for example, want to trick a parser. Really interesting, however, is that with generator functions, you can easily bypass the AngularJS sandbox. AngularJS is a JavaScript model view, whatever framework that is maintained by Google. And that is supposed to be one of the new IT frameworks. Like, it's an awesome framework that works in conjunction with CSP. It works well with Google Chrome packaged apps, with websites. You can just like put it into things, and it makes things very, very awesome and developers more productive. And AngularJS also features a very strong sandbox. Well, not very strong, but fairly strong. So the reason of this sandbox is that the AngularJS developers want to allow people to evaluate templating expressions and do this in a safe way. So to do this in a safe way, they must make sure that window, the critical object or location or document or any other critical object, is never being leaked. So cannot be accessed by, for example, an attacker who injects into one of these templating expressions. So they say, yes, we're going to take the template expression, we're going to parse it, and then we execute it in a sandbox so window can never be accessed and anything that is in there can be fairly safe. They meanwhile advise developers that the AngularJS sandbox should not be used as a security feature because it cannot hold indefinitely. There's always going to be some way of bypassing it. However, the easiest and most trivial way of bypassing it is simply using ECMAScript 6. Because what the sandbox does, for example, is trying to make sure that no one can evaluate any strings. So the parser checks that the objects that are being used in a templating expression are hopefully neither the window object, nor the document object, nor a HTML element, nor the function constructor. And to make sure that it's not the function constructor, they say, all right, if object is equals its own constructor, then it has to be function. And then they say, no, if it's function, we will not execute it, we will show you an error and say like, no, this is not possible, might be a sandbox violation. And they will deny your request of executing that code. And it's a fairly simple but very, very effective check. And so far no one managed to bypass this check. Well, with ECMAScript 6, you can do this very, very trivially. Because in this particular situation, you would be including the latest version of AngularJS, and you would have a scope definition here, and you would say, I have a safe function here. You would say scope safe equals function. And you have another example of code here, which would be unsafe, and you use a function generator or a generator function. And then you have the actual AngularJS application. So you would say, I have a templating expression here, and you would try to evaluate this thing, say like safe.constructor, and then evaluate a string. And AngularJS would say like, nah, this is a string, and this is the function constructor, and it smells like an eval, don't do it, and we'll block it. However, once you use the generator function, it will go through. Because the check that they have here, object equals object constructor, applies for everything, every single object in JavaScript, but generator functions. Because generator functions are functions that you can execute, but they don't have the function constructor, but a different constructor that exactly looks like this. It's not the function constructor, but the generator function constructor. So the Angular people have to kind of add this to the sandbox to make sure that this is not an eval sync and can be exploited. There was considerations to also implement generator arrows. Basically meaning they want to combine the feature of generators with the fat arrows. And people said, yeah, that would be cool to have like fat arrow generators, would be so useful, we could save so many characters. But then they realized that they can't do it because they messed it up. Because there's too many possibilities to collide with existing code or with existing syntax constructs. So you cannot create code that is indistinguishable or indistinguishably be a generator arrow and might not be something else, for example, like a multiplication or something like this. With functions it works, but with a fat arrow you can't do it and the parser cannot handle it. And there was a bunch of suggestions on the mailing list saying like, hey, we want to have this feature, like maybe can we do it like this? Foo, asterisk, parentheses, fat arrow, and then curlies? It's like, nah, you can't do this because this looks like multiplication, the parser doesn't know what it is. Then they thought about this, maybe we can do it like this. Let it generator equals 0, fat arrow, and then parentheses, and then we call this as a generator? No, this is just ugly code. And it looks like this, and they suggested this, and they suggested this, and this, and this, and this, and in the end they decided we can't do it. We kind of don't have the possibility to do it, so let's just better not do it at all and kind of ignore this whole thing. If you want to have a look at all the syntax suggestions that the specifier had and discuss on the mailing list, you can go here. You can see them, and it's amazing. Like, it's really amazing code constructs that not a human person can read anymore. Another interesting thing in ECMAScript 6 is the possibility to have new syntax for escapes. So in JavaScript, you can use octal escapes, you can use hexadecimal escapes, and you can use Unicode escapes. But the problem with the JavaScript or ECMAScript 5 Unicode escapes is that they have a fixed range because they're specified to start with a U and then with 4 hexadecimal digits. So it could be like A to F, 0 to 9. And it's basically specifying the code point in the Unicode table for the character that you want to express. But then came emoji, and everybody does emoji, like the universal language. So cat with a waving hand and a smiling face throwing fries at a dog, or something like this, absolutely relevant. And they decided, the problem is that these emoji characters are too far up in the range, so we cannot express them with 4 digits, with 4 hexadecimal digits anymore, so we need a new syntax. And it was decided to kind of use an encapsulation and say we have a syntax that uses curlies and then encapsulates the code point pointing to the character in the table and then closes the curlies again. Now, what is not so well known but fairly well known is that you can use Unicode escapes in JavaScript outside a string. Usually would say, hey, escapes are supposed to be used in a string because that's exactly what their purpose is. However, Unicode escapes you can even use outside the string, so this would really execute. So if you have this code construct here, \u0061 pointing to the lowercase a, alert1, you would see the alert1. That works in all browsers. And it is weird because it's the only escape that you can use outside strings. Hexadecimal escapes don't work outside strings. Octal escapes don't work outside strings. Those do. And in a way, those work also, like the new Unicode escapes, also work outside the string. So you can also do this, for example, \u, curly 0061, alert1, or even use a short notation and omit the zeros because they're kind of implicit, and just do this, u61, alert1. What you cannot do is, for example, replace the parentheses by one of these escapes. They are blacklisted, you cannot do this. You can only use alphanumeric characters, but that might be enough to bypass a sandbox or to bypass a filter and do interesting things. It is not yet clear whether this will continue working like this, because technically it's against the standard. So the only browser doing this right now, and I mean this, not this is being supported by all browsers, but this is only being supported by Internet Explorer right now. And if you read the spec very closely, you will realize that this is against the spec. So with this very, very fresh and very minimal feature, IE already went on and kind of violates the standard, which is not so good. If you try this, for example, in a non-browser JavaScript engine, you will get an error and say like, oh no, we cannot execute this. Hex digit expected, transferred, invalid Unicode escape sequence, and so on, yada yada. So you cannot execute this. And you should not execute this, but IE says like, yeah, you know, why not? Let's see where this goes. We don't know yet. And now there's an actual major change, because the things that we saw so far are kind of small and not so powerful. Yes, powerful, but not overly interesting. But the really interesting thing is templating strings. Oh my god, they are so good. This is a major change. Templating strings, or quasi-literals, or multi-line strings, because they all do the same thing and they kind of all have different names, give developers and attackers completely new syntax to execute code, entirely new syntax. It's absolutely amazing. The purpose of this thing is that they say, yeah, we don't have multi-line strings in JavaScript, so we want to have them. So how could we do this? And we don't have the possibility to use native templating in JavaScript, but we want to have this, so how could we do this? And we also don't have the possibility to use function tagging in JavaScript. So for example, having a string and prefixing a function and then directly executing that function on that string without really executing that function. We can't do this, but we want to do this. So let's kind of invent a new syntax where we can do this. And this syntax is just amazing, because this syntax introduces a completely new character to JavaScript that formerly was very, very unusual for JavaScript, which is the backtick. So formerly, the backtick in JavaScript could only be used in very, very scarce scenarios. So for example, the backtick was a valid character in one of the native regexp objects or regexp properties. So for example, if you have a regular expression and you're matching something like here, ABC, match B, you could do this. Select the character that is before the match, which would be $backtick. Or you could select the character that is actually being matched, that would be $ampersand. Or you could select the character that is behind the actual match, that would be $single quote. I'm not really sure if this kind of syntax is a great idea, but this is working in all major browsers and has been working for years. But now the backtick has like a new meaning, because we have the possibility to use the backtick to execute code. Of course, we can do harmless things with the backtick. We can just simply define multi-line strings. So we have the backtick here, ABC, a new line, and DEF, and then the other backtick to delimit this thing. But we can also do this. We can just simply say alert backtick 1 backtick. Like, no, this cannot be possible. Yes, this is possible. This works in Firefox, this works in Chrome, and then this works in IE, at least in latest version of IE in the tech preview. Like, this is crazy. This is really, really bad. You can also, for example, nest those backticks and chain those backticks and say we have the function constructor, and then we pass in a string, but we execute it at the same time with a backtick. So we have a backtick here passing in the string. Then inside that string have an escape backtick, then have another escape backtick, then have a backtick, then have another backtick and another backtick to execute the whole thing. And that would actually work. So take this string, throw it into Firefox on the console, and it will alert. You can also use the backtick, for example, in computed methods, in computed properties. We will see what this is later on by just doing a construct like this. You have an exclamation mark, then the curlies, then a computed property, executing alert with a backtick, and then null. So we have something that is completely passive, doesn't execute anything, but by prefixing the exclamation mark, we would force into a state that implicitly causes the execution to happen. Same with the plus, or measured throw shorthands. And of course we can concatenate this, so we can start a string, then we can leave it again, we can concatenate the backtick, the alert in, we can again use the backticks and concatenate again, and it will be executed. And there is another thing that is completely new, and that is expression interpolation. So not only can we execute functions with backticks instead of parentheses, but we also can execute from within one of these multi-line strings with, again, a new syntax construct. And this construct is $curly and a closing curly. So if we have a backticked string or a multi-line string and have an injection in there, then all of a sudden this character sequence will kind of execute code from within the string. So that means if you have any filter that is making sure that, for example, strings cannot be violated, strings cannot be broken, and everything, then you now have to also make sure that you detect the dollar and the curlies because they are an eval sync. Everything that is in here will be executed and evaluated. So that is kind of bad. I always kind of reference this with like the Backstreet Boys because they had this amazing thing. It's like Backstreet's back, all right, and we kind of internally say backtick's back, all right. But yeah, that's just me maybe. And the interesting thing is here what the backtick functionality gives back, because it gives you back an array that is referencing the single executed code points in here. So you have a function read, and you say, for example, read console.arguments, and then you execute this thing. So you execute the read function using the backticks, and then you have the expression interpolation inside the templating string. You will get a complex object back, which is an array saying A, B, C, D, E, F, G, and the indices. So there is even more functionality to it, and we might expect that there's going to be more in the future. Now you might ask, okay, is there any attacks? Is there anything where we can actually use this to bypass things or to do stuff? And amazingly, yes, there is many ways of using this new feature to bypass existing filters. One thing, for example, is this. Who knows this? This is, needless to say, everybody knows it, the syntax of the regular expressions that are being used by Internet Explorer to filter XSS attacks. So that's basically, in essence, the IE XSS filter. This thing, this kind of guards a website when you inject something via URL or via post parameter, and then says like, this looks like an XSS attack, I should be blocking this. These are the regular expressions. Now, who can find the vulnerability? Well, it's of course very easy. The vulnerability is here. Because they also guard from executing functions, so they detect things like alphanumeric strings that then end with parentheses. Well, this is kind of pointless to do because you don't need parentheses anymore to execute code. So the filter is completely bypassed. Like, it's absolutely meaningless because you can just use the new language features in IE to bypass IE's XSS filter. So what? And I would believe that they would have real big problems actually fixing this because the new syntax possibilities are so complex that you cannot just go ahead and craft a regular expression that is bulletproof. That is not possible. According to rumors, we can expect that IE might even remove the XSS filter and completely rely on CSP, but that's like a different story. So we can bypass this thing. That would be no bypass. So this would be detected because it uses parentheses and actually matches the regex. But this would be bypassing the filter completely because there is no matching regex at all, and there will not be any, most likely. And this bypasses it, of course, as well. So the filter does detect access to the location object, but not if you obfuscate it using the unudicate escapes, for example, and then use the backticks to execute code or assign arbitrary functions to it. So that wasn't even complicated. So we can see that these new syntax additions make it extremely trivial to bypass existing filter methods. Similarly, we see this having effect on Flash. And you're like, why on Flash? Well, in Flash, you don't have too many possibilities to filter user input unless you're doing it yourself. So developers define blacklists or whitelists in Flash, and those blacklists/whitelists usually focus around the parentheses and say like, yeah, you can use everything here, but you cannot use parentheses because that might be weird or execute code, so we kind of prohibit parentheses or make sure that only characters are allowed that don't involve parentheses and some other characters. Well, then again, this of course completely will be completely bypassed by the backticks. There is a tool that is called the JPlayer. I think it's one of those many Flash video players, and they have a security mechanism internally that is watching for dangerous characters, which is the double quote, the single quote, the curlies, parentheses, the asterisk, the plus, and the slash. But of course, this is meaningless right now because we have the backticks to execute code, and therefore bypass the protection and have yet another ODE. I mean, it's nothing big, but it's working in many other Flash files because this kind of functionality can be seen in many files because Flash developers don't have too much else to use for security. So if we, for example, want to execute arbitrary payload with JPlayer, and we tried it in the classic way, we would be saying JPlayer SWF jQuery equals alert1, and the filter would say, nah, you cannot execute this because I detect this to be bad. However, if you do this, you have a bypass. So whenever you test against Flash and you notice that there's some blacklisting functionality enabled or in use, try the backticks because they are most likely going to get you through. Then there's another thing which is quite amazing, and it's one of these mystery features, which is symbols. So symbols are one of the features that everybody looks at and says like, I don't really know what that is. What could that possibly be? What kind of use do they have? It's really weird, and it's kind of hard to describe the meaning of symbols in JavaScript in one sentence. I think MDM puts it quite well and says a symbol is a unique and immutable data type that may be used as an identifier to object properties. The symbol object is an implicit object wrapper for the symbol primitive data type. So I think now it should be perfectly clear what symbols are, right? Well, maybe not. Another sentence to explain this would be, in contrast to symbol, the symbol for function creates a symbol available in a global symbol registry list. Symbol for does also not necessarily create a new symbol on every call, but checks first if a symbol with a given key is already present in the registry. Like, all right, what are symbols? I don't get it. And there's also well-known symbols with special symbols. And you could say well-known symbols that can allow to change object properties and have magic powers. And that is indeed the fact, they do have magic powers. So with a symbol, you can in fact create a unique, immutable reference to something. So something that can never be touched again, you create it once, it is absolutely unique and can never be touched again, which is quite useful, for example, for indexing. But with symbols, you can also change the nature of native objects and make them do something else, something different from what they're supposed to do. So for example, you can say, hey, array, you have an iterator, right? And hey, string, you don't have an iterator. Let's just borrow the iterator from the array and put it to the string so we can iterate over strings natively. And that works, just like this. But the most interesting thing here is the symbol toString tag. So when you have an object that is complex and you turn it into a string, then a serialization happens and you see a representation of that object. If you turn, for example, window into a string, you see rectangular parentheses and it says object window and then the closing rectis. So it says object window, that is not particularly useful, but now you can change that using symbols. So you would say object prototype symbol toString tag and assign a string. Coincidentally, it's like an XSS attack. And then you would say location equals JavaScript 1 plus object, which starts a serialization process on that object, and all of a sudden, the object is not saying object anymore, but exactly this string here. So this is bad. And we have the possibility, and that is the real magic part, to kind of cross-domain influence the nature of objects. So if we have a framing website, like a parent framing website, that redefines the native object prototype, and then we have a child website on a different domain that uses one of those objects, for example like this. Here we define it on evil.com, say symbol toString tag equals this. Then we have an iframe that is framing good.com, and good.com accessing top. Then top will actually have that value that it was giving by evil.com, despite the fact that it was coming from a completely different domain. So this trick here is one of the ways to execute JavaScript, arbitrary JavaScript with very few characters, because you just have to say write top, and that's it, because top would be this, because it would be inheriting this from this symbol toString tag, and therefore contain any payload that you want. So this is one of the possibilities to extremely shorten payload and make sure that everything gets through, even if you have character length restrictions. This might also be a possible CSP leak. So you have the possibility to, for example, map the value of document cookie to the toString tag, and then, for example, leak that thing via an iframe or even via a pop-up. So if you do this on an injectable but CSP protected website, and you map document cookie in this property, then you just open a pop-up from that website with, for example, a link, href target something, something, or window open, and then all of a sudden you can access opener, and opener will then contain document cookie, so you leaked it because, well, it's now that value despite CSP. Otherwise you could not leak it, but in this particular situation you can. And the good thing is, and this should be like one of the last features to show today, is that you also have the possibility to create two-string tags that are actually valid syntax. So you can go ahead and say object prototype symbol two-string tag equals 1, alert 1, and then you have this thing, and the consequence of this would be that the serialized string representation would look like this, and this is fully valid JavaScript syntax. So you can shape this thing in a way that upon serialization it will yield working and valid code, and therefore, again, for example, escape sandboxes. So this is one of the more crazy features. Mysterious and kind of hard to understand, but if you see what you can do with it, you have like a good baseline to start exploring. There is more to come. There's a bunch of more symbols to come, not on this two-string tag and the iterator. So we have iterator, we have unscopable, we have the symbol has instance, toPrimitive, isRegXP, so you can, for example, turn objects into regular expression objects even if there are not. I'm not really sure why. And for example, is concat spreadable, so this defines whether a concat call on a certain variable or on a certain primitive will have an effect or not. And while this is all not a huge problem in JavaScript, it starts to become a problem once you have JavaScript and the DOM, because in the DOM you have magic and critical properties, and in combination with those functionalities, security vulnerabilities might arise. But the point is, we cannot really play with this too much for now, because only Chrome supports most of the symbols that are being are supposed to be available. IE doesn't yet. Firefox, I think, supports the iterator, but none of the others yet, so we still have to wait for support and see what's going to happen. And last but not least, we have modules, and modules are going to give us the possibility to, for example, use includes in JavaScript, which we couldn't do natively before, but now we can. And again, the syntax is crazy. So we don't need any parentheses anymore to import arbitrary code from other domains and execute it, but we just do it like this. We say import curly's $from, and then an arbitrary URL where our payload is, and it will be imported and it will be executed immediately, because we control this and we just have to inject this. Or like this. Or we can do it like this. Or we can even do it like this and do like this. So if you want to filter against this kind of thing, against this injection, you're going to have a hard time. And the only thing that you have to have on the other domain would be this construct here. You would say export function and then execute any arbitrary code. You can already play with this, but not in the browser, but only in Traceur, one of the JavaScript engines or one of the ECMAScript 6 compatible engines that is available out there. I think Google actually created Traceur or supports it. And almost last but not least, there is the possibility to use reflection in JavaScript, so it's going to get like a brand new shiny reflection API, which gives you the possibility to instantly execute code even if you don't have any parentheses or anything to do so. So once you, for example, want to call a function, you just take the function object, you throw it into the reflect apply or into one of the reflect APIs, and then it's going to execute without any further ado. Reflection is extremely interesting because you have the possibility to execute the native state even if someone before that tried to tamper with the object. So it gives you the possibility to make sure that you really execute what you want to execute and no one changed it before you, and kind of gives you unexpected results. Oops, that was a click that didn't go there. So if you, for example, want to use reflect on Internet Explorer to execute arbitrary code, you could use the reflection set API and say reflect set, then window, then you want to kind of reflect on location, and you want to set location to JavaScript alert 1. So all of a sudden you realize you have yet another eval sync thanks to the reflection API. You can also reflect on inner HTML. So if you have a document and you say reflect set document body inner HTML and just set arbitrary HTML, then it will be set, so yet another eval sync. So even reflection is going to be exciting, but the only browser supporting it right now, as of now, to my knowledge, is indeed the new version of Internet Explorer, so we have to just wait and see how this develops. And there is some mixed salad before we reach the conclusion. So you have the possibility, for example, to use computed properties. In ECMAScript 5, you could be doing this, ABC, and map 1, 2, 3 to this. In ECMAScript 6, you can do this, so you can execute arbitrary code inside the value, inside the label for a property. This never worked before, so if you have an injection in here, as I mentioned in the very beginning of this talk, then this all of a sudden works. Likewise with this, you have computed accessors, and you have the possibility to, for example, create crazy syntax like this. Use like an accessor that is even obfuscated by using base 64, and then executing it by just using the parentheses and adding the alert and the executable code afterwards. You also have the possibility to execute code that is in parameters. So if you have an injection into a parameter of a function, you can do this, function A, and then equals alert1, and it will execute. Never worked before, shouldn't work, but does now in ECMAScript 6. And you have also, of course, also the possibility to use something that is similar to the Reflect API, which are promises, and you can just like take a function that is anonymous and not executed yet, and simply throw it into a promise, and that will be executed. But that is not so spectacular. And there's more to come. So we see proxies, loaders, realms, classes, and many, many more things that will be implemented in ECMAScript 6, and we don't really know yet how they're going to be looking like. So to finalize this talk and to reach a conclusion, ECMAScript 6 is already here. We have it in browsers. It's being implemented, and it changes a lot. What we've seen right now is a few features, but definitely not that all of them. So if you're interested in this thing, you should definitely have a look at this table again, because it is almost updated daily and the best reference to learn about ECMAScript 6. And if you are indeed a penetration tester that is working on web penetration tests, then ECMAScript 6 is very, very, very important for you, because it gives you a whole new set of tools that you will find very useful during your testings. So here's a small collection of links and material. It's not that much yet, and it's going to be extended because there is not yet that much in terms of documentation. But what is there is listed here, and you can have a look at this. We also release a paper about this that you can find here that describes in a bit more detail what the attacks are that you can carry out using ECMAScript 6. And I hope this kind of list gives you more of an introduction and kind of pointers to have like further research on the topics. So having said that, this is the end of my talk. I hope I gave you like a good introduction to this new language that is working in your browser, and some inspiration to find new tricks, find new bugs, find new features, and hopefully like start to discuss those things and see what else is going to happen. That is it for now. Thank you very much. If you have any questions, please have them coming. Do we have time for questions?